So before starting today's lecture, I'd like to correct something in our definition of outer measure. So this was the previous definition I gave. It's the infimum of the collection of approximations from above. And I'm going to make a minor correction due to something that someone in the class brought up. So what I mentioned before is that as long as we assume x itself is in our original set, fancy A, as long as we have this, I said that the collection of approximations from above of any given B subset X will be non-empty. And so this infimum is well defined. So this is what I said. This will always be non-empty. But that's actually not strictly true. So my argument for why this is non-empty is that you could use just singleton x, just x itself, as your cover of B, and consider your approximation from above of B to be the sum of the mu's of everything in this collection, which consists of one thing, and so your sum would just be mu of x, which would be a sort of finite sum, and therefore it would correspond to a convergent series. But do you see the problem with my phrasing here? I said that we should consider sequences of sets that cover your set here, and so that does not allow for finite sequences, right? Like, really, maybe the best thing you can come up with that's like just using x to cover it would be to repeat x like this in a sequence, x, 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 x forever. But then the series would not converge necessarily, right? If mu of x is positive, then mu of x plus mu of x forever, that's probably not a convergent series, right? It's definitely not a convergent series if mu of x is positive. So there are a few possible corrections we can make. One thing we can do is actually throw in an additional assumption and say, okay, we're always going to require at least that the empty set be in there, and that mu of the empty set be 0. And I don't know of any situation that's useful where you don't have this. Maybe there is, but I've never seen it. Usually you have at least this stuff. And then you can use sort of x and then empty set, empty set, empty set forever as your sequence that covers any given B. And then that would sort of simulate just using x. That would simulate this finite cover consisting of just x. And then the sum of the mu's of all of these, since mu of the empty set is assumed to be 0, that would just be mu of x. So that's one solution, is to require this. Or another solution might be, and this is the solution I'll accept, I guess, is to allow this to be a finite collection. So instead we can say an is an at most countable, finite or countably infinite collection of sets in A that covers B, such that the sum converges, where the sum is to be interpreted either as a series or a finite sum, depending on the size of the family of sets. So that way works. But so this is really a minor point, since you typically would have this stuff too. You would have these assumptions holding, so I don't think this will really affect anything. But thank you to the person who pointed this out, since I do want the definition of outer measure to be perfect.